I have some bad news, folks. Your conference experience will soon be drawing to a close, but wipe those tears from your eyes because we have one more amazing speaker left for you to enjoy before we call time on this year's conference. Ladies and gentlemen, boys and girls, and friends from beyond the binary, please allow me to introduce your final speaker of this year's conference. It is NADER from Seattle in the USA. NADER is a senior developer advocate with AWS, and in this talk, NADER is going to be exploring some of the strange, unusual, and interesting ways GraphQL has been used. We know of all the typical ways that we are using it, but there are a few surprising implementations out there. I'll leave NADER to fill you in. Please join us for the Q&A session after this talk, and as always, keep posting along on social media using the hashtag CityJS2021, as well as keep those comments rolling in wherever you are watching along online. NADER, it is my honor to hand the stage over to you for our final talk of the conference.
All right, so happy to be here. Thank you for the introduction. This is a live talk. So I'm coming at you right now from Mississippi. So it's a pleasure to be here. And I know that this is kind of the last talk of the conference. So if you're still hanging out, you might be a little tired. So hopefully you enjoy this talk and then you can enjoy your weekend. So let's go ahead and get started. My name is NADER DABIT, and I'm going to be talking about turning the cloud inside out, creating a cloud programming interface with GraphQL. Like I mentioned, my name is NADER DABIT. I'm currently working as a senior developer advocate at Amazon Web Services. I lead the developer advocacy team at the front-end web and mobile development team. I'm also an author, a teacher, and I've done a lot of open source as well. My most recent book is from O'Reilly Publications. It's called Full Stack Serverless, touches on some of the stuff I'm going to be going over in my talk today. I know that Jan Sui was on here a couple of hours ago. He talked a little bit about some of the stuff. I think you'll see a little bit of overlap, but in general, I'm hoping that you still take a lot away from this talk because I'm going to be diving into some interesting spaces like even Ethereum, as well as general graph APIs across different third-party services, as well as working with AWS. So this talk is kind of broken up into 4 main parts. We're going to talk about what GraphQL is and why it's so popular and gaining in popularity. I'm going to talk about the philosophy of the ideas that I'm going to be kind of trying to get around during my talk. I'm going to look at how to actually implement these ideas into the cloud using AWS and CDK. And then I'm going to walk through some code and do a live demo. So let's talk about GraphQL. And you may already know a lot about GraphQL, but let me talk about the reasons that I like GraphQL that kind of go into why other people also might like it as well. So what is GraphQL? It's an open source data query and manipulation language for APIs, and it's a runtime for fulfilling queries with existing data. So to actually put that a little bit more concisely, or maybe more easy to kind of like grok for someone like me, it's a replacement for a REST API. It's an alternative for a REST API, but instead of not really having a defined interface, you're given a typed interface. So GraphQL works really well with modern front-end technologies that people are working with today, like TypeScript and even Dart on the mobile side. Dart is gaining popularity with Flutter, things like that. So GraphQL works really well with a typed front end. So why do people use GraphQL? There's a lot of reasons. Let me talk about the overlap between what other people like and what I like. First of all, and one of the most important things for me is type checking. You get type validation and type checking out of the box. This is just built into what GraphQL is. With a traditional REST API, you might be able to get some of, something like this up and running, but it's not part of the specification, and every API is going to end up looking a lot different. Another big thing for me and for a lot of people is that real time is part of the specification. When you're building real time into your application, you might consider using something like WebSockets, maybe polling, or even server-sent events. But the implementation is typically going to look different across different APIs. you're rarely going to come across two APIs that you've worked with that have this real-time implementation implemented the same way. But with GraphQL, you can count on the implementation being, actually the implementation will be slightly different, but the API for you to consume will look exactly the same. So when you learn GraphQL once, you can typically work with real-time data across multiple APIs, working across multiple companies, regardless of who actually implemented this API. With GraphQL, you can work with a single API call to request all of your data versus multiple operations. So for example, you might think of a situation like your mobile app or your web application where you have like an onload function that calls data or calls an API to fetch data. So you might need something like your user profile. You might need a list of products for an e-commerce site. You might need to get a list of items that are on sale, and then you might need some other data. With the REST API, you typically have to fire off multiple HTTP calls for this. With GraphQL, you can actually bundle all of the different operations that you want into a single API call. And in addition to this single API call, you're also working with a single endpoint. So your entire API layer is running off of a single endpoint. So you don't have to manage multiple endpoints for your API. The only thing you're working with are the actual queries and mutations and even subscriptions. The next thing that people really like about GraphQL is query efficiency. So with query efficiency, you're basically preventing the overfetching or the underfetching of data. So when you build out an API with GraphQL, you typically are going to have ways to interact with that API. You're going to have queries for reading data. You're going to have mutations for writing and updating and deleting data. With a API like something like, for instance, a to-do API, you might have a to-do type that has maybe a dozen or so fields. With a traditional REST API, you might have to implement some functionality that allows you to either have multiple endpoints to fetch variations of that to-do. So you might want just the title, you might want the title and the completed value, and then you might want just the ID, and these all might be separate API calls. With GraphQL, you only have to write this implementation once, and then you can fetch whatever data that you like. So you might want all of the data for your web application main view. You might want a subsection of that data for your mobile application, the initial list that shows up maybe when the app loads. You don't have to actually write any more logic, no more code on your back end. All of these different queries are just available for you from your initial implementation. So another big one is API documentation. And in GraphQL, this is known as introspection. And GraphQL introspection is the ability to query which resources are available in the current API schema. And then given the API via introspection, we can see all of the queries, we can see all of the types, all of the fields, and all of the directives that the API supports. So me as a GraphQL developer or an API or a front-end developer even, I can like walk into any API, not only within my company and my team, but also anywhere in the entire ecosystem and know exactly what's going on. I can look at this API and it's going to read the same across every company, every implementation, and every graph. They're all going to be implemented differently under the hood, but exposed to me in the exact same way. Another thing is API evolution. So, oops, looks like I went forward one too many times there. Evolving an API usually means having to keep up with the old version until teams kind of make the transition to the new version. So with REST, it's often common to offer multiple API versions. But with GraphQL, it eliminates the need for versioning by deprecating APIs on a field level. So aging fields can be later removed from the schema without impacting the existing operations. And then GraphQL enables that by creating a uniform API across the entire application that isn't limited by a specific storage engine at all. And then finally, these last two kind of really speak to the idea behind this talk. This one is consistency. And I kind of mentioned this already. When you learn GraphQL, you don't have to learn it again. You can actually use the same skill set across every single application that you work with after that. And me as a developer, I like to learn things that I can then kind of learn once and reuse. So for me, some of examples of that would be something like React. I can learn React, I can build mobile apps, I can build web apps, I can build desktop applications, I can even build VR, AR, all types of stuff. The idea is like I can learn once and I can write this anywhere. I think the same idea applies to GraphQL. Once you learn GraphQL, you can actually start working with anyone's API almost immediately. You know exactly how to do this, and it doesn't take any time to catch on to what's going on. So imagine how many times you've actually needed to go into someone's documentation to understand how to interact with the API. So for me, lately, I might have gone into the YouTube API to check it out. I maybe want to go into dev.to to kind of query some of my posts. I have to learn how those APIs are implemented. If it was built in GraphQL, I would know exactly how to do that, and I would also be able to read the documentation. So the idea with GraphQL, it's kind of learn once, create, read, update, delete, and subscribe anywhere, meaning you can just learn GraphQL once and be efficient for all of the times that you use it going forward. And then the next one is microservices. And this also speaks a lot to what I'm going to be talking about in just a moment. And microservices are a great, GraphQL is a great fit for complex systems and microservices. So really by implementing multiple systems behind its API, GraphQL unifies them and hides all of their complexity. The server is then responsible for fetching the data from the existing systems and packaging it up in the GraphQL response format without you needing to really know what's going on under the hood. You can just ask for the data that you need and everything is kind of handled for you. Now let's take a look at the anatomy of a GraphQL API and what GraphQL API kind of looks like. With GraphQL, you typically have three main parts. You have your schema that defines your data, fields, and operations on your data. You have your resolvers, which are essentially business logic that map your schema operations to your data sources. And then you have your data sources, which are typically going to be databases and microservices, but they could be even static content or hard-coded content. So let's take a look at the schema. This is kind of a really basic schema for a simple API, you could say. We have a few different types. We have a transaction type that has a few different fields. We say that a transaction has an ID, an amount, a user, and a product. And a user is a type of in itself, and a product is a type in and of itself as well. And then to interact with these different types, we have our mutations in our queries. So for instance, if we want to create a new transaction, we have this create transaction mutation. And this is essentially kind of like a HTTP method for creating versus with GraphQL, it's called a mutation. The next thing we'll look at is the resolvers, and the resolvers can be thought of as functions or handlers for business logic between the schema operations and the data sources. So for instance, when we want to query for transactions, we have this list transactions query. This is going to really just be calling some type of business logic. It can be a function, it can be a server somewhere, execution environment is what it needs to be. And then it's going to return the data in the format that we like. So you could think of the resolvers as some type of execution environment, some type of place where you can run business logic. And then finally, the data sources. And data sources can be really whatever you like them to be, but typically you see them being databases, microservices, serverless functions, or even HTTP endpoints. So let's say you have an existing microservice endpoint, you can make that endpoint in itself a data source. So when you invoke a query, that query actually calls that other HTTP endpoint and returns some data for you. So that's a quick overview of GraphQL. Let's look at GraphQL adoption though, because I'm always interested to see like where the industry is headed and like where people are enjoying working within the ecosystem. So GraphQL is definitely mainstream at this point. A few companies that are using it, AWS, Netflix, Twitter, Uber, Peloton, Reddit, GitLab, PayPal, Shopify, Lyft, GitHub, Facebook, Starbucks, NBC. All these big companies are using it. And there's also a lot of smaller and medium-sized companies using it. The growth is definitely there. More and more companies are continuing to kind of use GraphQL, and you're seeing the adoption continue to rise. Another thing that I typically like to understand is developer sentiment. And developer sentiment is kind of important to me, engaging what will continue to be a thing and what will kind of die out at some point. And because at the end of the day, if developers are doing a certain thing and enjoying it, it's much more likely to not only stick around, but probably to get even better and to get even more adoption in the future. Now, I guess these survey results don't really tell the entire story, but they do tell me that developers enjoy using GraphQL, which tells me a lot. I care about what developers care about because I kind of care about understanding where the industry is headed so that I am headed in the same direction. And this is kind of like just a personal preference, but I think it's served me well to make sure that I'm not spending my time investing in something that isn't going to be there in 5 years or in 2 years. So with that being said, let's talk about the next portion of this talk, using GraphQL as an API gateway in a couple of different ways. The few ways that I'm going to be talking about are microservices. I'm going to go a little bit deeper there. I'm going to look at how to use GraphQL as an API gateway to third-party public and private APIs. I'm going to look at how to use GraphQL as an API gateway to Ethereum and blockchain. And then I'm going to look at and the main core of this talk, how to use GraphQL as an API gateway to the cloud. So let's look at microservices. So a traditional API gateway, well, let's look at a really basic, maybe naive implementation of a microservice. You might be a microservice architecture. You might be hitting different endpoints. So you might have various endpoints scattered out, and these different endpoints are different HTTP endpoints altogether, and they're not consistent at all. So to kind of improve this, a lot of people put an API gateway in front of their microservices. This gives you a little bit more consistency, but it also gives you a place that you can do things like authorization and authentication and fine-grained access controls and security type of stuff, and other things maybe around scalability and load balancing and things like that. But what we're seeing a lot of customers doing in AWS, and I'm seeing this a lot in the industry as well, is people are just dropping in GraphQL as a replacement for this traditional REST API gateway. Because doing this, they're going to get all the things that they want out of their GraphQL, out of their API gateway to begin with, but they're going to inherit all of the benefits of GraphQL. Type checking, real time for any mutations, query efficiency, API documentation, all of the stuff we kind of talked about earlier. So this is already kind of a thing. This isn't anything I would say that's that revolutionary, because this is becoming pretty popular at this point. But that kind of lays the groundwork for building additional things on top of this idea. One of those things is this idea of bundling other APIs into a single graph. And one of the most interesting projects I would say out there that's doing this is OneGraph. OneGraph bundles all types of different third-party APIs into a single graph, allowing you to have a consistent API layer across all of these different services and all of these different APIs. So imagine if you've ever worked with services like Stripe or Twitter or Gmail or YouTube or any of these, they all typically have different APIs, maybe except for GitHub, which now does have a GraphQL API. The really, really great thing about OneGraph is that you can query data from all of these APIs. APIs like Airtable, Cloudflare, Dev.to, Dribble, Dropbox, Google, Meetup, Netlify, Salesforce. I think there's a few dozen, YouTube, Twitter, Trello, Stripe, and you can do this all from a single graph. So you can kind of say, I want to query some of this data from Stripe, and then you can jump into another part of the graph from within that graph. And let's take a look at a quick demo of kind of how this looks actually. So this is OneGraph here. And if I go to the left-hand panel over here, I'm not sure how much I need to zoom in, but you can kind of see all of the different services that you can interact with. So we have all of these options that we can query from. And when you're doing this, you're kind of getting this consistent GraphQL API layer, which is super nice for me, because every time I've ever wanted to mess with any of these APIs, I typically spend a lot of time digging through the docs and trying to understand how they do things. But with something like this, I can just say, okay, I want to query dev.to. I want to get the articles, and I want to get the cover image, the title, and the URL. I might even say, I want to say only from, oops. Actually, I'm trying to remember there's a way to query for just my own post, but I'm kind of forgetting the argument that I need to pass here. Let me zoom out a little bit here. I don't remember what my argument needs to be, but basically you can also, of course, like pass in arguments to like query for just your own posts and stuff like that. But I guess the general idea here is really the fact that you can kind of, you know, query for all of these different types of APIs from GraphQL without learning each individual one. Once you learn GraphQL, you can kind of do all this, which to me is like super cool. So we'll continue now. The next thing I want to talk about is blockchain and Ethereum. And in this space, there's this idea of a decentralized app, or as they call them, dApps. And these are starting to become more and more popular. A lot of people are building financial applications, typically in this space, where you can pay with things like cryptocurrency and things like that. There's an entire ecosystem around this, you know, lending and borrowing, token swaps, investments, crowdfunding, all types of stuff. And I think one of the most popular ones that's out there that people are using is Compound. Compound is a money market protocol built on Ethereum, and it allows any person or machine to easily earn interest by lending their cryptocurrency assets. The lent assets can then be used as collateral to borrow against other assets locked in a protocol. Anyway, so it's not really about Compound, but this is just one of the many apps that's built out there. But let's say you wanted to kind of interact with, you know, with one of these APIs, one of these services. You know, they have their own APIs and stuff like that. But in general, when it comes to GraphQL, I'm sorry, when it comes to blockchain data to begin with, is as it stands, you can't really build great applications directly on top of blockchains like Ethereum. And the problem is that you need to have data indexed and organized for efficient retrieval, which by default it isn't. And traditionally, in the world that we live in, this is done by databases. So when you think of something like the web in general, how would we query all of the information that we would want to find if there wasn't something like Google? And Google kind of works as the indexing layer for the web. We want to learn how to do something. We don't start going and looking at different websites trying to find a link to the right website that we want to go to. We just go to Google and type in the thing, and we're given some results. So in this decentralized stack, though, that indexing layer was missing, and it was impossible for someone to actually build this in a decentralized way, because that would kind of break the contract of what decentralized apps are meant to be. And then this is kind of where the graph comes in. The graph is an indexing protocol, and it's an indexing protocol for querying networks like Ethereum and IPFS. Anyone can build and publish open APIs that they call subgraphs, making data more easily accessible. So this is essentially a GraphQL API on top of blockchain. Before the graph, teams had to develop and operate their own proprietary indexing servers. So they had to kind of index all this data themselves and store it on a server. And this required significant engineering and hardware resources, and it also broke the important security properties and philosophical properties required for decentralization. The graph solves that by offering this consistent indexing protocol itself, and it does so using GraphQL. Anyone can build and publish open APIs called subgraphs that make this data easily accessible. A lot of companies are already using the graph. Compound and Uniswap are a couple of the big ones, as well as companies like Foundation, which is a marketplace for like NFTs and stuff. So those are kind of the interesting use cases that I'm aware of, that I'm really interested in. The graph, along with OneGraph, I guess graph is like a common theme here, and as well as microservices. But what I've been super passionate about in the last couple of years, really the last year and a half or 2 years, is when I've really gotten interested in this, is how this applies to cloud computing. And out of all the things that I've learned in the 3 years and 3 months I've been at AWS, this is kind of the thing that stands out the most to me, and the thing that I'm really most excited about. So when you look at the AWS dashboard, me as a front-end developer, as a JavaScript developer, me as an app developer, when I first look at this console, it's extremely off-putting. It was very confusing. It was hard for me to understand what I'm supposed to be doing here. That's because AWS has so many different services, right? Like you come in here and you're like, oh, I just want to I want to have some data. I want to store in a database. I want to query it. And then I want to authenticate a user. And then I might want to upload an image. Like that's all I cared about. I did not care about a lot of this other stuff. So I want to kind of talk about how GraphQL can solve that. So let's conceptualize how we might apply a GraphQL API to something like AWS. For me, I might, like I mentioned, I want to have some data and I want to be able to save that data and I want to be able to query for that data. So we might build something like a simple graph where we have a product type and we have a label type, and these have different fields. But at the end of the day, it's about the different access patterns. And I might want to store some of my data in DynamoDB because I want to have this lightning fast execution environment for high scale data. I might want to have Elasticsearch because I might want to also be able to query for geospatial data or some type of really complex search that isn't supported by DynamoDB. And then let's say I might even want to do something even weirder. I might want to interact with a machine learning service like recognition. I might have the need to run an image through an AI service to kind of give me an idea about what's in the image, because I might want to be able to detect labels or something like that, or I might want to be able to translate something from one language to another, whatever. I want to take advantage of that. So I want to be able to do this all from a single API. So the really cool part is that we can actually do this pretty easily within AWS. And I would like to talk about how we can actually make this happen. So here I can query DynamoDB for this query. I can call search for products from Elasticsearch. And then for my last query, I can talk to the machine learning service, which is recognition. With, excuse me, for this graph here, I might want to execute multiple operations in a single query. So here, we're going to be calling get account information. Get account information returns a user as part of the account type. We also need to get an order, and we're going to basically be invoking multiple data sources within a single operation. So we're hitting DynamoDB to get the user. We're hitting a separate table to get the orders, a separate request to get the products, and then we're bundling everything back and we're returning a single account type. This includes the orders and the users in a single operation, which is super powerful. And I mentioned earlier about interacting with GraphQL with a single request to query for multiple pieces of data. So for instance, I mentioned this idea of an onload function where I want to request multiple pieces of data within a single request. So let's say for our desktop application, we have different needs because we want to be able to support a larger, we have a larger window that we can actually show people information on. So we're going to query for more data. So in the onload function, I'm going to hit the list queries query. I'm going to hit the get user query, the wish list query, and the on sale. And I also want to get specific data out of that. And I want to just have that ready. So we have that ready. We can do that, right? So what's really interesting though is what if I want to reuse these same queries, but I want to ask for different information? I can do that as well. I don't need to change any backend code. In this example for my mobile app, I don't need that last query for wish list. All I need is list products, get user, and on sale. And I don't even need all of the data. I only need, for instance, the ID, the name, and the avatar for the get user. So these are the things that we want to do with the cloud. So we want to basically be building cloud APIs with GraphQL. So let's talk about how we can actually get that done. There's three main things in my opinion, like someone that came into this, that learned this in the last few years, the things that made sense to me, breaking it apart, I would say there's three main pieces. There's the execution environment, there's the permissions, and then there's the AWS SDK. These are the things that you have to kind of keep in mind. So when we talk about the execution environment, there's typically two main ways that you can go about this. You can have a server full or a serverless execution environment. And server full is just the meaning that you have your own server. So if you have your own server, you're only limited really by the operating system that your server is running on. So you have a lot of flexibility. You have full control over all the aspects of the server environment. Now, this comes with trade-offs because with all of that flexibility, you also have to build out a lot of this functionality yourself. So you have to implement the subscriptions. You have to implement things that will scale. You have to implement it in a way that will scale. You have to implement caching if you want that. You have to actually manage the server itself. And you also have to deal with security. You have to deal with authentication, authorization, all that stuff. So in addition, when it comes to security, to all of the typical security implications that you have to consider in a server environment, like DDoS attacks and so on and so forth, you also have to take into consideration GraphQL specific considerations, like malicious queries, which can basically be mitigated with things like recursion depth limiting, or having a mechanism in place to calculate the complexity score for queries coming into the system. But you have to actually know how to do that in all this. So if you're building this yourself, you have to kind of have a lot of depth of knowledge to get this right. And then there's serverless, and there's two main ways you can go about this in the serverless realm. One is using AWS AppSync, and the other is using Amazon API Gateway with AWS Lambda. But API Gateway is kind of built for a REST API. You would have to do some work to make this work well with a GraphQL layer. So I'm going to be focusing on AppSync, which is focused on a GraphQL layer. It is a managed GraphQL API service from AWS. And if you heard Jan Sui's talk, you probably already learned a little bit about AppSync. So the good things about AppSync is that it has all the stuff that I talked about kind of already built in. So we have security, authentication, and authorization built in. We have subscriptions that scale to tens of millions of connected clients for a single API endpoint. We have scalability and resiliency built in. Caching is built in. It is serverless. The payment model is also serverless. So instead of a capital expense, you have a variable expense. You're paying for the usage that you have. And you also just have less code, which is a great thing. Now, what are the downsides though? Because there are downsides, and there's no black and white. There's always a gray area. So for building in this way, the downsides are that you're limited by the API service that's provided by the service. So you're limited by, when you use a managed service, you're just limited by what that service offers. And often if you need something that isn't there, you might have to wait weeks, months, or even longer if it isn't a priority for our team or that team to actually build that thing. So if you need something that is a blocker, you're not able to get that because you are, again, working with a managed service. And also if you're using a high or consistent scale over an extended period of time that you can determine in the future, serverless can be more expensive. It's typically less expensive, but let's say that you're going to be getting 1 million requests per minute or per hour over the course of 3 months or 2 weeks, whatever. If you know that and you can take that into consideration, you can often build that yourself for less expensive than something like AppSync, which is serverless, that you only are going to pay for the actual compute time. And then also you have to take into consideration long-running tasks, which is something that you can't do in a serverless environment really at all. The next thing we'll talk about are permissions. So that's the execution environment. Let's talk about this idea of permissions, or in the AWS world, identity and access management, or IAM. And IAM kind of confused me when I first started AWS, but when I kind of really broke it down to what it is, it made a lot more sense. So let's say we have a Lambda function that we have created, and we have a DynamoDB table that we've created. And we want to talk to this DynamoDB table from our Lambda function. For instance, we want to say, let's get the posts from the table, right? Well, by default, you cannot do this. When you create these different services in your API, in your API, I guess, but also in your account, you have deny by default. What we do want, though, is to be able to set some permissions. We want to be able to then go and say, okay, since this is deny by default, I want to add this permission to this function to be able to create, read, update, and delete from this exact table. And then when I call this request, then everything succeeds. So IAM are just the permissions between the function in the table or the service in the other service that you want to happen. And then once you've set that, then everything is good. And it is pretty much as simple as that. Implementing it can be done in a few different ways. So you can actually use JSON to do this, or if you're using something like Amplify, it does it for you, or if you're using CDK, you have methods that do this for you. And we'll take a look at CDK in just a moment. So we've talked about the execution environment, we've talked about the permissions. Let's now talk about the SDKs. There are a few different AWS SDKs. So if you're working with Lambda, you can work with Go, .NET, C++, Ruby, any of these execution environments. And all of these different SDKs allow you to interact with all of these different AWS services. So for instance, we're going to be working with Node.js. So with DynamoDB, we might say we want to scan a table and get all of the items. To do that, we're going to go ahead and import DynamoDB client and the scan command, which is all from the new version 3 of the AWS SDK. We're going to then create a scan command, and the only parameters that we need to pass in are the table name. And as long as the permissions are set up, that like we talked about a second ago, then this operation is going to work from our function. And then all we need to do is call the .send method, passing in the parameters, which is this command variable. The next thing we might want to do is interact with the machine learning service. So again, the API looks similar in the sense that we create like this parameters object where we pass in, some different parameters. In this case, we're setting an image property, which is referencing an S3 image, an image that's stored in S3. Here, we're just going to call client.send, and we're using the detect labels command, meaning that we're going to send a reference to this image to this machine learning service. It's going to do some detection, and then it's going to return back a JSON object with the metadata about what's in that image. And we do that with fairly a short amount of code. We do all of this with only really four lines of code, and in addition to maybe the handler itself. So you could probably do this in like 10 or so lines of code. So with that being understood, these things, so how do you actually put all this stuff together? So all of these things individually sound fine, and you might be even a little bit confused because each individual thing by itself doesn't make sense individually. What I like to see is an end-to-end solution or some cohesion. Let's talk about the different deployment options, because this is kind of how you put all this stuff together. There are a few main ways to do this. And if you are a front-end developer like me, I would say the ways that make the most sense are the serverless framework, AWS CDK, and AWS Amplify. If you are kind of an intermediate to advanced level developer and you want a lot more control, you might want to use SAM or even CDK or CloudFormation. But as a front-end developer, as an app developer, I think CDK, Amplify, and serverless framework are kind of the easiest ways to get into this. And what we're going to be looking at in this case is CDK. So let's go ahead and take a look at a demo. What I'd like to do is kind of walk through what this might look like if we want to build this ourselves from scratch. And CDK is infrastructure as code, and it stands for Cloud Development Kit. And you can basically write your infrastructure as TypeScript or Python or whatever your favorite programming language is. And for me, that's going to be TypeScript. So what we have here is an entire GraphQL API that we've built in about 52 lines of code. And what we have built is kind of like a GraphQL API that goes into AWS, exposing it via a GraphQL schema. And we want to interact with two different types of APIs to kind of demonstrate what's going on here. We want to interact with a Lambda function that talks to DynamoDB. And we also want to interact with a Lambda function that calls another microservice, in our case, another HTTP endpoint. So how do we do that? Well, first of all, just like any Node.js projects, we have our package.json. And what I've done is I've installed the different dependencies that I want to work with. So I know I want to work, first of all, core comes by default in the CDK project, but I want to work with Lambda, DynamoDB, and AppSync. So all I need to do is npm install or yarn add AppSync, CDK, and DynamoDB. I'm sorry, AppSync, DynamoDB, and Lambda. And then I can now import these, and I can start using these constructs to create infrastructure. So the first thing I want to do is when you create a new CDK project, you're going to have this lib/ the name of your project.ts file, that is your infrastructure as code. And it will come to you looking something like, if I go ahead and remove the code that I've written, it looks something like this, okay? So you just have this constructor, and then you have the call to super, and then you're working within the class below it. And then you write all of your infrastructure as code here. So we're going to be starting like right here. And what I want to do is I want to create a GraphQL API. I want to create a Lambda function. And I want to create a DynamoDB table. Those are the three things I need. And I want them to be able to work together. So to do that, the first thing we do is we create a new API. The API is an AppSync API, and we do this in about 8 lines of code. To do that, we say new AppSync API. We pass in the scope, and we pass in an ID. And this can just be any string. And then here we're setting the name. And in my case, I want this to be called City.js API. And we're setting the default basic authorization configuration. And in my case, I just want this to be a public API. And the most public that you can make this is with an API key. Therefore, anytime you want to call this, you just pass the API key in the header and you're good to go. So now that we've created this API, we want to now start referencing it. And the way we want to reference it is we want to reference this API to add a new data source to this. And then we're going to start building out the rest of our API. So the data source that we want to work with is a Lambda function. So we now need to create this Lambda function. So we've created the API. Here we're creating a new Lambda function. And here we're passing in a couple of parameters. We're setting the runtime to like Node.js 12.x, but let's make this 14.x. We're setting the handler name. So we need to have some code somewhere that's going to be like running the execution environment. And we're going to create a function called main.ts. And we're going to have a method within that called the handler function. So here we're kind of setting the handler as main.handler. We also need to define where our code is going to live. And it's going to live in a folder called lambda-fns. So there we have our functions, our function location, which is going to be right here. So we have our Lambda functions. We then say that we want to add a data source to our API. So we say API.add Lambda data source. We give the API an ID, and then we pass in a reference to the Lambda function. So we've created the API, we've created the function, and now we kind of map those two things together. We're saying we want to add this Lambda function as the data source, and now we can map the GraphQL operations into the Lambda function. And the way that we do that is we create 3 resolvers. We create a query for listing posts, a mutation for creating posts, and a query for searching images. The create post and list post is going to talk to DynamoDB. Search images is going to talk to the Unsplash API. And then finally, we want to create our DynamoDB table. So we say, we create a table and we say new ddb.table, passing in some metadata around making it serverless, paper requests, and then setting the partition key. And then to enable the IAM permissions like we talked about, we just say post table.grant full access, passing in the Lambda function. And then we add a couple of environment variables. The first thing we want to reference is the name of the table. We want to reference that in our function. And we also want to reference the Unsplash API key, which is how we actually talk to that Unsplash API with our private API key. And with that, I'm going to go ahead because I know I'm running close to being on time. With that, we also have to create our Lambda functions, which are already here. And then we have to create our schema. So let's just take a look at the schema and then the main entry point. So the schema that we're working with has an image type. It has a URLs type, or URL type, I'm sorry. The image type has a URLs property of URL, which is basically going to show the Unsplash images. So that's our 2 Unsplash types. And then we have a post type for our DynamoDB table. And then we have a query for listing posts, a query for searching images, and a mutation for creating posts. And we map those into our main entry point here in main.ts. And into the handler here, we invoke the various functions using the field name. And the field name is going to basically be list posts, search images, or create posts. So we can basically switch over those. We can say create posts, list posts, or search images, depending on what it is. We want to invoke a different function. And this is kind of how it all works. So we built, the infrastructure is code in about 60 lines of code. We probably have another about 80 lines of code in our Lambda functions total. And now we can kind of like go and test this out. So if I go to the AppSync console after running CDK deploy, I can go to queries and we can go ahead and query this data. So I'm going to go ahead and query list post. There should be nothing there because we haven't created any. So let's go ahead and create mutation, create post. And then we'll be done with the whole talk. And then you can go get some sleep. All right, so let's create the post. We're going to list posts. So now we're getting the post coming back. And then the last thing we want to do is query for search images. We want to talk to the Unsplash API. All right, so for our query, we might say French bulldogs. And we get the image. We should be able to go ahead and search and check out the French bulldog. All right, so that's about it. That's the end of my talk. I hope you learned something. If you want to learn more about how this works, check out the AWS mobile blog at aws.amazon.com/blog/mobile. The Amplify docs. I would also check out this blog post, GraphQL core features, architectural pros and cons. And then the last thing I would check out would be dev.2. I actually have a blog post called Turning the Cloud Inside Out that kind of walks through a lot of this and actually has a code example for you to be able to use that kind of maps to the stuff I talked about here. That's it. So thank you for watching my talk. I'm sorry I went a couple minutes over. I hope you learned something and I hope you enjoyed the talk as much as I enjoyed being here. Thank you.
NADER, what a brilliant talk. Thank you very much for wrapping up this year's conference in style. I'm sure everybody watching along at home will be joining me in giving you our customary round the world round of applause. NADER's Q&A session will be starting over on GatherTown right now. So if you have any questions related to GraphQL or any of the other topics mentioned in this talk, please do join me in giving NADER a grilling on our Q&A session. Don't forget, keep posting along on social media using the hashtag CityJS2021. It would be great to know what you have thought of this year's conference. And if you are watching along on YouTube, GatherTown, or anywhere else that this conference may be being broadcast, please do keep the comments rolling in. Once again, NADER, thank you very much for that superb talk. NADER, what an amazing talk. That was the perfect way to finish this year's CityJS conference. Thank you very much for finishing it on a high. I'm sure you think that we saved the best speaker till last. Am I correct?
Well, that's very kind of you.
But I love the fact that you are keeping your ego in check.
Well, I'm a big fan of like all the speakers that have come before me, actually. So I can't speak highly enough of all of them. So I'm actually honored to even be in the same lineup as a lot of them. So anyway, happy to be here.
I would agree with you. I'm honored to just host Q&As with them, to be honest. It's been pretty amazing. We've had a question come in, so I think we'll dive straight into this because we've only got 15 minutes. What do you think of typed GraphQL solutions like Prisma?
I have to say Prisma and the team behind it have innovated so much in this space. It's amazing what they've done. I mean, I would say that even a lot of what you've seen in the managed GraphQL solutions like that are out there were heavily influenced by their earlier work. So I'm a huge fan of Prisma, and I am a huge fan of what they're doing now. I know they've pivoted a few times, but what they're doing now with this ORM solution, that's a consistent like API layer, is really, really, really great. It's really powerful. I think that I am waiting until they support maybe a few more database mappings for me to actually use it, because I use a lot of DynamoDB. And from what I understand, they don't yet support that, but they do have really rich support for like SQL. Yeah, I think it's great. I'm a huge fan, and it doesn't really, I would say, fit in directly to what we're doing with AppSync, but I've actually seen people maybe use it with AppSync in some way, and I think they were doing it in Lambda or something like that. But I haven't actually gotten a chance to use it with AppSync yet. But I love it, and I think that that team is really great, and I'm a big fan, and I would recommend checking it out if you haven't already. I see a big future there as well.
Yeah. Is that something that you think AppSync is moving towards using, or is it not?
It's just a different, it's just a different thing altogether. Like with AppSync, you define your schema using just traditional SDL. We have a few of our own directives, but you're using a traditional GraphQL schema, and we then take that schema. And if you're using Amplify, we actually do a build on top of that, and we generate additional resolvers and mutations and queries and stuff. But it's our own SDL, it's our own like schema definition language, and it doesn't really play nicely, I would say, with anything else that's really out there.
Okay, fair enough. It doesn't play nicely. Let's not play with it for that use case, I guess. So obviously you're here representing AWS at the moment, one of the sponsors of the conference. And one of the things we've been asking all of our sponsors and the representatives of them is, what is coming in the pipeline? What kind of secrets can you give away for the AWS platform or any of the individual products in that ecosystem?
I mean, there is two paradigms right now that seem to be like both gaining a lot of momentum at the same time. There's the people that are building with Kubernetes and containers and Docker and all this stuff, and that ecosystem is continuing to grow and do really well. And then there's the serverless ecosystem, and that is also exploding and gaining in momentum. And I think it's just like a rising tide, like lifts all boats. There's more and more people building cloud in the cloud. There's more and more people needing to scale their businesses. So I think that there's a lot of innovation and you know, people and the company actually investing money in both of those ecosystems within AWS. So you should see a lot of interesting things coming out of the Lambda team. There's a couple of brand new services that are coming out that are in both of these spaces, the low code and no code space within AWS. The Amplify team, we've just gone through the largest expansion ever by far, between the end of last year and then going into this year. We have a huge amount of goals and stuff that we're working towards toward the end of the year. Our team is going to grow just this year by more than we already have already. So we're almost like, you could say, doubling the size of our team, which is never even close to happening. We usually grow by like 5 or 10 or 15%. So like just the growth that's happening in the serverless space and the container space, a lot of innovation happening. So you're going to see stuff, and you could kind of usually bucket the things that are coming out in one of those two areas. I can't speak to anything specific. Something that I'm excited about, though, that I can speak of, with Amplify, we're releasing SSR support, native SSR support for hosting, meaning that you can deploy, you know, Nuxt and Next.js without having to do anything. It's just built into the service, and we support API routes and SSR routes and stuff like that. The other thing that I'm really excited about has to do with GraphQL and AppSync. Right now, what I kind of demoed was using Lambda as the execution environment, meaning that if you wanted to write your business logic, you write that in a Lambda function, and then you talk to a database. There is another way to use AppSync, and it is mapping GraphQL operations directly to your data source without Lambda. So you're kind of saving the execution time, startup time, which is kind of known as a cold start, but also whatever costs that you incur in that execution if you bypass that and go a direct resolver. But right now it's a challenging thing to do because you have to write in a language called VTL, which is velocity templating language. And it's something that people are not too familiar with, and it's hard to debug. So what we're building is actually JavaScript resolver support. So now you can actually write your resolvers and map your GraphQL operations directly to your database, bypassing Lambda using JavaScript. So it's going to be really, really powerful and popular feature. A lot of people are asking for it, and it's currently in beta alpha testing actually internally. So we should see that in a couple of months.
That's
I would
pretty
say a couple of months, maybe within the next 3 to 6 months. So I don't really want to say anything too early.
No, come on, let's put the pressure on. 2 months. Let's go with 2 months. Come
That
on.
would be nice. That would be nice.
When you were talking then, you mentioned low code and no code situations. I wasn't aware that AWS did anything for that paradigm. Is that something that's growing within AWS, or is it a new thing? Or
Yeah, I mean, some of the most popular things that we've launched in the last year have been in that space. So Amplify Admin UI is a graphical user interface for managing your data and managing your app backend. So you can go into the admin UI, you can create an authentication service, a database, you can map your GraphQL you can map your database operations to scope them to authentication. So you can kind of set up your authorization configurations within the admin UI. And then in the future, we want to enable people to add functions and S3 storage and all of this stuff into a single interface. That's been one of the most popular things we've ever launched. And that was launched in December of 2020. So just maybe 3 or 4 months ago. The other thing is Honeycode. Honeycode was launched in the middle of last year, I believe. And it's an AWS kind of low code solution that's gotten a lot of, gained a lot of momentum and super powerful as well. And I would bucket both of those maybe in that space, but we have a lot more stuff that's being worked on.
oh, nice. Well, that's exciting because I think low code and no code are ways to get new people into the industry, and that's a personal passion of mine. It's something I spent a few years doing, so it's great to hear AWS are supporting those kind of people. I want to take a step back and talk about Jamstack more generally. It's been a hot topic of this conference, and there's always seems to be a battle between Jamstack and kind of more monolith architectures. Do you think that the world is tipping more towards being Jamstack based in terms of software, or do you think there's always going to be a huge proportion of the industry built upon monoliths?
I think the pie is just expanding so much right now. The pie is getting so much bigger that there is room for a lot of growth in all of these different areas. So I think that Jamstack has its use cases, but if you look at all of the different original thought leadership blog posts and stuff around Jamstack, it was basically centered around the idea of a static site. But I think what you're really seeing is that people are going way beyond static site generation. Next.js is becoming extremely popular. It's kind of outgrowing what Jamstack is. If you look at a lot of the talks by Guillermo Roch, or I forgot if that's how you pronounce his name, he's basically talking about beyond the Jamstack. I think that people are outgrowing the idea of the Jamstack for a lot of these more modern solutions. I think it still fits certain solutions, but I think that what you're kind of seeing is kind of outgrowing the general idea of what Jamstack was meant to be, because you're now able to do so much more with API routes and SSR support and all this other stuff and fallback routes with Next.js. So you have your Jamstack stuff, you have your things that are kind of bigger than that, like what Next.js and Vercel are doing. And there's room for all of these things to grow. So I think that they're all going to continue to be around. If I had to bet on something though, I would probably say that what Next.js and Vercel is doing, that it's expanding outside of just the static site, is kind of what I would consider more as the future of what's happening in the web today. And then a lot of people agree with that, I think.
Yeah, it does seem to be a popular, well, maybe not a popular opinion, but certainly one that other people have got. It's come up a few times over the course of this conference, which is nice to hear. It's nice to see that these technologies evolve. They don't just lump up as one thing and that's all they are.
And Vue also is great. Vue has amazing community, and they're doing similar stuff with Nuxt. And I know there's other things that are happening there. So yeah, all this stuff is really cool. But I think getting past the static site is where we're headed.
Yeah, past the static site. Is that the title of your next talk?
Maybe.
Let's escape the static sites. Fantastic. And so I would like you to imagine a world where anything is possible. You can implement anything you want. If you had carte blanche to do anything with the AWS platforms and introduce something completely new for you personally, what would that be? Is there something that comes to mind?
I mean, if we were going to bend the laws of what's possible, even with technology, and maybe push the limits, it would be a low code solution that has a very, very approachable escape hatch. So I think if you could think of something a GUI that allows you to set up all of your infrastructure, but you have Lambda functions or some type of execution environment where you can write business logic to map all of the different interactions that are happening. And then on the front end, having something like what DraftBit is doing with React Native. There's a few other things out there that are basically UI generation for the client side code as well. And then putting those two things together and giving kind of like a low code solution for front end and back end with the escape hash for business logic, and then allowing the developer to kind of really build quickly. So like I could go in, I could like create my UI, I could create my back end, I could connect them. And then when I need that custom business logic, what is everyone needs, because you need to set aside your business needs to be set aside usually by having your own, proprietary code. You need that somewhere. That goes in that escape hatch. That would be really cool. And I think that the future is going to be looking something like that.
Yeah, you think we're going to get to that point? Because I was going to ask,
One
what's
day.
stopping us? You've got an amazing team at AWS. Why haven't we got that already?
It's
Come
hard.
on,
It's
pull your
so
finger
hard.
out.
It's difficult. All this stuff is really challenging,
Yeah.
So
Definitely not easy stuff, but it's interesting that you say that that's the low code thing is kind of the future. To a conference full of JavaScript developers, that
well,
might
I
not
think
be the
low
best
code
news.
doesn't threaten anyone here. In fact, it liberates them. We're able to now use our skill set to do the more interesting stuff, which is essentially like writing our own custom like business logic type of stuff and our own, building out our own ideas as opposed to implementing the same type of features over and over. Like I've written a button a million times. Is that really what I want to do? No, I want to like, do something more interesting maybe. At least that's kind of me. That's me talking, and I don't expect everyone to agree.
Oh, I'm sure everybody agrees that they don't want to be creating a button for the millionth time.
Yeah,
There's nothing exciting in a button. Well, I don't know. There might be. I don't know. So let me find out a little bit more about you. You are obviously well known in the developer community. You speak at a lot of conferences. What I want to know is, what do you do for a side project when you're not working? And it doesn't necessarily need to be code based. Tell us a little bit more about the man.
so for lately, I really like spending time with my family. I like to eat. I like to cook. So typically, when I'm not doing something with code or something, I'm hanging out with family. But really, and this is just purely like who I am and whatever. I just really like to write code. So like even when I'm off of work on the weekends, I'm typically in my computer reading or learning something about coding. I typically am reading and learning something that either coincides with what I'm doing at work or it's completely something different. But I'm never like in my free time doing work. I'm more like, oh, I want to like, I've seen this thing at work and I want to like dive into this other thing that's going to maybe complement it one day. So I might do that, but I'm not going to just go and work on the weekend. It's usually me just exploring stuff. And then, but then there's the completely opposite stuff that I like to learn about. So for me right now, I'm really interested in like the decentralized finance space, like what I kind of talked about in my talk a little bit. Blockchain stuff is kind of interesting to me. I think what you see happening in Lebanon and what you see happen in Venezuela and other parts of the world with this massive inflation and government controls over banks, there's a great opportunity for improving the world with a real decentralized banking solution. I don't know what that's going to look like yet and how that's going to happen, but I think it is happening as we speak.
It's certainly people's minds are changing about that as a concept. I think if you rewound 15 years ago, people have pushed back against that. But I think now people are seeing the value. NFTs, any interest to you or?
I mean, not really. I think I'm happy to see people being happy about doing their own thing, and I hate to ever to be like someone that falls and says something negative about them. It's not my thing, but I really am happy when I see other people being happy and excited about something. So I'm happy for the people that are in doing stuff like that. So more power to them. But I haven't really dabbled in that myself.
No. You should be a politician, by the way. That was a brilliant way of saying it's of no interest to you whatsoever. Fantastic. So we found out a little bit about we found out a little bit about AWS. We didn't get to find out about what you do with when you're learning and you learn a new thing with software or technologies. Do you throw together a little side project, a test case? Do you publish that? Is that a blog post? How does that come out into the world?
Yeah, it just depends on how far removed I am from that thing. But like right now, like I mentioned, I am learning some new stuff, and this is very far removed from where I'm at. So I'm kind of like throwing the entire book at myself, trying to like learn. So I'm going from like uh, code that other people have written to my own projects to books to YouTube videos to asking people questions on Twitter to meeting with people. Like I'm doing everything I can to kind of fill my brain with the context around this because it's
Mm.
all so new to me. But I think repetition for me is the only way that I can actually learn something. So I keep going back at it, doing it over and over, and then it just starts sticking. And that's the only way for me to kind of like learn something. I can't just like read one thing and read a different thing. I have to like stick to one thing and keep doing it over and over. And then like once I kind of get that going, I start expanding and then expanding from there. And then, one day I'm able to speak confidently about it, hopefully.
Fingers crossed.
Repetition.
That might be next
Yeah.
year's conference talk. But I completely agree. Repetition is the mother of all learning, right? If you don't repeat something, you don't learn it, you don't internalize it. End of story.
I love that. Yeah.
There's so watching this now or in the future, there's going to be a lot of people who are going to want to end up career-wise where you are. And this is our wrap-up question, by the way. They want to end up where you are. Do you think that your enthusiasm for learning is a necessity for getting to where you are in your career, or do you think that you don't necessarily need to spend weekends and evenings learning new things to support your career? What's your
Absolutely. I don't think that anyone has to do that to
no?
be. And in fact, I know so many really, really accomplished people that are in this space that kind of just come and they do this on their 9 to 5, and they go and do other stuff in their free time, and it's not like even their passion, and they're really great at it, and they they speak at events and stuff. So it kind of there's a huge spectrum, but so I wouldn't say anyone has to like be a certain personality trait to kind of like get to there. But if you do want to become if you do want to like become someone that speaks at events and maybe becomes in developer advocacy or relations, one of the okay, two things. One of them is creating and sharing stuff. So when you create something, I don't know, it seems like positive things happen. Like I love the idea of creating and putting it out there. It's a very uncomfortable feeling when you create something and you expose it to the world, because you're often going to attract negative comments and stuff, but you're going to grow because people are also going to be giving you a lot of positive comments. You can take the positive and the negative together and improve. And but also people like to see new things, and they get attracted to the idea of new things. Sometimes I think when I see someone creating and putting new stuff out there, I often am attracted to that person as like a creator, and I want to follow them and listen to what they're going to be doing. So I'd say create stuff. And then the other is like this idea of like being a bridge builder. There's this talk that was given by Aaron Frost that I watched at NGConf, I think it was, in Las Vegas a long time ago. And it was probably the most memorable talk that I'd ever seen before. But the talk was basically about giving back and recognizing all of the things that other people had done in order for you to get to where you are today. And I think this is especially having to do with it being someone that's a developer, that's a self-taught developer, as all of us are. Even the people that went to college, they often admit they're just self-taught developers, because once you get out of school, you're not done learning, you're always learning. And most of the stuff that we learn is actually written and put out there by other community members, whether it be a conference talk or a blog post or a example project or a YouTube video or a podcast. All these different things are kind of out there. And all of these people are doing this stuff, and they're basically building bridges because they're taking the things that they've learned and they're passing them on to help other people get to where they are today. And there's a couple of things that come out of this. First of all, you're helping yourself, because when you're publishing stuff, people are becoming like aware of you and they know who you are. But you're also helping those other people to get to where they are, like where they want to be one day. So it's like a win-win situation. And like I would say, be a bridge builder. Look up the blog post from Aaron Frost about becoming a bridge builder, and maybe even look for that talk called Building Bridges from Aaron Frost.
Yeah, I will check that out myself, and I'm sure people watching along at home will do too. So that is pretty much all we got time for Q&A. But before I let you get back to your day, there are some rapid fire questions that we've been asking every developer who's taken to the stage today, just to try and survey the land and get answers to the important questions. So first up, tabs or spaces?
Spaces.
Good man. Front end or back end?
I mean, I'm a front end developer. Even though I love both, I would have to, if I had to choose one, it would be front end.
Good man. If you could only use one for the rest of your life, would you pick Angular, React, Vue, or something else?
React.
React, nice. And finally, apples or bananas?
Bananas.
Yes. That means we finish on a draw. I've been doing this all the way through, and apples have been winning. Bananas came back today, and you've just tipped it over. Fantastic. Thank you very much. Nader, it's been a pleasure to talk to you. I'm sure everybody has watched your talk, and you'll be getting lots of follow-ups online and elsewhere. If you're watching along on GatherTown, I believe there is an after party coming your way. You might need to head to the secret room, but shh, I didn't tell you. Nader, once again, thank you very much for being a part of this year's conference. It has been an honor and a privilege to be your host.
Thank you, Tony. It's been an honor to be here. And thanks everyone for watching. And I hope you enjoyed the event and have a great weekend.
Excellent.
Bye.